So today we talk about linear approximations, and this is actually rather easy since we talked about tangent lines before. And in particular, the tangent line at a point a, f of a, is also called the linearization of f or the linear approximation of f. The idea is you have a function which might be complicated to be evaluated, but maybe it is easy to find the linearization. And then you can use the linearization to estimate values for the original function f. So here's a procedure how this works. To find the linear approximation of a function f at a point a, you find first the point a and f of a. Well, and then we need the slope, right? For the tangent line we need the slope. The slope is f prime. So second step is to find first f prime of x as a function. And then we find f prime at a, which is the slope of the tangent line. And then we find the tangent line completely, so that is a function y of x, which is f of a plus f prime of a times x minus a. So then the linear approximation is f is approximated by y, and y is given by the linear function f at a plus f prime at a x minus a. And then this wiggly, wavy equal sign, this means approximately equal. Let's do an example where you see how this works. So we try to find the linearization of the function f of x is ln x plus 5 at a is equal to 1. And then we want to use it to approximate the values for ln of 5.98 and ln of 6.01. So let's just follow the steps which are outlined before. So find a and f of a. A is 1, as given in the problem. F of a is ln of 1 plus 5, which is ln 6. Then we need to find f prime, and then evaluate f prime at the point a. So let's differentiate the function f. Differentiation of the logarithm gives 1 over. So this is f prime of x is 1 divided by x plus 5. And there might be an inner derivative from the chain rule, because x plus 5 is the inner function. But the derivative of x is just 1, so the inner derivative doesn't really show up. So f prime is 1 over x plus 5, and then f prime at a is f prime at 1, which is a sixth. Okay. And so then we use the formula for the tangent line, which is f of a plus f prime at a x minus a. And we can sub in everything we have. We know what a is, we know f prime at a, we know f at a. So we get ln 6 plus 1/6 x minus 1. This is the tangent line. Let's look at this graphically. Let's see how it does. Here we go. So here I show the function f. This is ln of x plus 5. And then the red line is the linearization. Y of x equals ln 6 plus 1/6 x minus 1. And you see here at the point 1, bim, 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 boops. So here we have perfect tangentiality, right? So the red and the blue curve, they overlap, and the red touches the blue very, very smoothly. Now, if we go away from 1 a little bit, so maybe a little bit to the right or a little bit to the left, then you see that in this region here, the red line is still very, very close to the blue line. We built this red function at the point 1, but now we want to use it a little bit off this point. So maybe between 0.5 and 1.5, it looks like the red and the blue are really identical in this little interval there. So that's the idea behind the linearization. And so in the final step, we use it to evaluate a few points. So I want to know what is log of 5.98 and natural logarithm of 6.01. And again, I said log for ln. That's what I do. I like it. Log, 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 log. ln, 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 log, 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 ln, ln. So the natural logarithm of 5.98, I write it as this. This is 0.98 plus 5. And now this arises exactly as it arises in the function x plus 5, or ln x plus 5. So x is 0.98. So this is in fact f at 0.98. Okay? Now 0.98 is in fact really close to 1. We have chosen a as 1 up here. So then we can use our linear approximation. So this is approximately equal y at 0.98. Okay? And then we just need to sub it in. So this is log 6 plus 1/6 0.98 minus 1. And now we have something for our calculator. So let's plug it in. And we get, let me just look at my notes, 1.788. Now, if you calculate this directly on the calculator, you find ln of 5.98 is 1.788. Okay, so we get the same thing from the linear approximation. Of course, if you have a calculator, you do the calculator directly. But on the other hand, in some cases, you might not. For example, in exams. And then it's always good to know the linear approximation. Okay, let's do it for a log of 6.01. So then this is log of 1.01 plus 5, right? So this is the function really evaluated at 1.01. 1.01 is close to 1, so I can use the linear approximation. Then this is y at 1.01, so meaning ln 6 plus 1/6 1.01 minus 1. And again, we can figure this out, and this is 1.793. And then taking the calculator directly, ln of 6.01 is the same, 1.793. This linear approximation works really well if you stay close to the point. Close to the point a is 1, then you can do this. Let me summarize. So let me explain in the summary a little bit how to find the linear approximation of a given function f at a point a. So you need to do the following 4 steps. First, you find the point a and f of a, and then you find the derivative f prime of x and the point f prime at a. And then with this information you can find the tangent line with slope f prime at a through the point a f of a, and here is the formula. Y is f of a plus f prime of a x minus a. And then the linear approximation is given by the linear function. So f is approximately equal to y as long as x is close to a. Okay, Tolo, did you get this? Oh, well, never mind.